A diffraction grating with A diffraction grating with n lines per meter is used to deflect light of various wavelengths lambda. The graph shows a relation between the deflection angle theta and lambda for different wavelengths in the nth order interference pattern. What is the gradient of the graph?
Okay, so we know the formula for diffraction grating is n lambda equals to d sine theta, right? Now, if the graph is given of sine theta versus lambda, so we have to make them subject. So it would be n over d equals to sine theta upon lambda, right? Now we have to see now that n over d. What is this n over d? So we already know that the formula for d is 1 over n, where is n, capital N is equals to number of lines per meter, right? So just substitute it there. The formula would be n 1 over n, forming n into capital N equals to sine theta upon pi upon lambda. We already know that the gradient is y upon x, so the sine theta over lambda is a gradient, so it is equals to n into n. So A would be your answer. Is it clear?
Yes, sir.
So now read 27 MCQ.
A parallel beam of red light of wavelength 700 nanometers is incident normally on a diffraction grating that has 400 lines per millimeter. What is the total number of intensity maxima from the grating?
Again, you need total number of intensity max, right? In simple words, they are asking total number of n, small n, the number of which means number of order, right? Total number of orders. So now keep one thing in your mind that whenever they say total number of maxima or they say maximum number of maxima, the angle you would be taking is 90. The angle you would be taking is 90. Why? Because you know when the diffraction happen on the screen as well, the maximum diffraction can happen is to the angle 90 because we know that this is can be like this or this could be like this. Diffraction would happen like this, but the maximum would be if I make angle 90 from it, it would be obviously on this straight. Yes or no?
Yes.
Because we know that angle always come from start. Angle always come from the center one. You always take the angle from the center. This is your center bright fringe. Okay, you can take the center. And now maximum would be 91. Because this is your slit. Before it, there is nothing. This is your slit as well. So before it, there is nothing. You have shined the light here. The light source is here. And this is your slit. So this is your angle 90. That's how the maximum number of intensity is possible. Is it clear? So whenever they say maximum number of intensity maximum, you have to take angle 90. Because if we take angle 100 or 120, it would be something like this. So it is not possible. As the slit position is your at 90 degrees. So before it, it is not possible, and after it, it is not maximum. It would keep like this, and then maximum would be at 90 angle. Is this thing clear?
Yes.
So angle would be 90, and then we have to find again the formula is n lambda equals to d sine theta. We have to find n, so it would be d sine theta upon lambda. So we have the wavelength, we have the angle. What don't we have? We don't have d. So we know the formula for d is 1 over n. So you can take N as what is the meaning of capital N?
400.
Yes, 400, but you have to convert it. So divide by exponent minus 3 would be then come above. So it would be 400 into exponent 3. Okay.
Yes.
So now just calculate it and tell me the number of N. Quick. This would come above. Yeah, so you got 3.57, right? So I was making the slit like this. So told you that the center bread fringe would be like at here on the screen, right? So I said the maximum number of fringes are possible, or maximum number of maxima are possible when the angle is 90, because the maximum diffraction could take place is 90, this angle, right? So I told you at one place. But what about downward as well? If there are 3.57 lines here, so obviously here would be 3.57 maxima as well. Yes or no?
Yes.
So the answer you got is of only one above side. Center bright, you can say lines above from center bright fringe. Now you have to take lines downwards from center bright fringe as well. So just multiply by 3.57 by 2. So the answer would be 7. So 27 is your answer. Sorry, part B, 7 is your answer. Is it clear now?
Yes.
So the thing is, the conversion of D is, we know that N is equal to number of lines per meter. So now there were 400 lines, but it is written per millimeter. So you have to convert because to meter. So we know that it is per. You know, per means in fraction. So we have to convert it to meter. Now it is in meter. Now it will come above. So that's why I wrote exponent minus 3 in denominator because of per millimeter.
Okay. So 3.57 is the lines from above the bright part, from the above bright part.
Yes, yes. Above the center bright fringe, you can say. Okay.
Okay, so
Okay, now read this MCQ 30.
monochromatic light is incident on a deflection grating and a diffraction pattern is observed. Which row shows possible effects of replacing the grating with one that has twice as many lines per millimeter?
So you know whenever they say replacing this thing with this thing, we have to use formula because we have to see the effect of it. So the formula is n lambda equal d sine theta for diffraction grating, right? They are, what are they doing? They are replacing the grating. So they are increasing d, right?
The D is becoming 2D.
So first let's make d the subject. It would be n lambda over sine theta. Okay, so not exactly d. They are making the number of lines twice. So I have to convert d to the form 1 over n, right? Now you can say they are making now this n to n, right?
Yes, sir.
So now Bring this to n in the numerator, it would be 2n equals to n pi over, no, it would be it would become inverse as well. So sine theta over n lambda. Now you can say if we increase number of lines, what would happen? Angle would also increase due to direct relationship. Now tell me, if we increase number of lines, what would happen to number of orders?
It will decrease because it's inversely proportional.
Yeah, so B would be your answer there. Is it clear?
Yes, sir.
Now read 39.
A two-source interference experiment uses the apparatus shown. What is the main purpose of the single slit?
Yeah, so for single slit, you can say first thing is to make a narrow beam of light. And diffraction does not make narrow beam of light, it spread the light. Yes or no?
Yes, sir.
So because of single slit, it won't be narrow beam, so it is wrong. To make the same amplitude of light incident on each slit, that's also not possible because when diffraction happens, you know the center would be higher amplitude, but the area, if you go downwards, it would be of lesser amplitude. Yes or no?
Sorry, sir?
I was saying that when you the light diffract, the center bright fringe, you can say the center fringe would be of higher amplitude, but the other fringes, which is not on center like this one or this one, they would be of lesser amplitude. Yes or no?
Yes.
Because I told you the center would be the brightest fringe. So brightness depend on intensity and intensity depends on amplitude. So they are directly proportional. So amplitude is not same. Amplitude would differ. Now the another part C is saying to provide coherent light. Now to provide coherent light, what does coherent mean?
The frequency in the lambda is more.
Now the main point was constant phase difference. Yes,
Constant phase difference, but
the
there's also the
yeah, you were right that the constant frequency, same frequency as well, but the main point was constant phase difference. So we know that whenever the light diffracts, so we can see there that phase difference is constant because when a phase difference is constant, then the interference can happen. So this point is right. Okay, so part C is right. Now the part D is to provide monochromatic light. So to provide monochromatic light is not a responsibility of slit. Light is being provided by lamp. Okay, so to provide monochromatic light is the responsibility of lamp. That's not of slit. So that's why it is also not possible. So part C is your answer. Is that clear?
yes, sir.
Okay, now try solve MCQ 42 and tell me the answer. What do you think answer would be?
Okay.
MCQ 42. Read MCQ 45.
The diagrams show the diffraction of water waves in a ripple tank as they pass through a gap between two barriers. Which diagram is correct?
Which diagram is correct? Okay. Yeah, so we know that first let's cancel the wrong ones.
He cannot be.
which cannot be.
C.
Yes, C is not possible, right? And anything else? Option do you think is right?
D is not possible.
Yeah, D is not possible as well
So
because the
it's
wave should
either,
be, yes, because the wave should be proper diaphragm like this, proper curves. It should be either A or B. So
or
see,
B.
in A or in part A, the thing is that the waves are being diffracted, but they are not. You can see that they are
That,
not being diffracted almost all over the place, but it is being in constant path, like a very short path. Yes or no?
yes.
So that's why. And one more thing, the distance between the wave. This is your wave fronts. What? This is your wave fronts. So distance between the wave front is your wavelength. If I say what is the distance of this? This is your wavelength. This is your lambda. Right? This is your lambda. So this distance should be also your
Um,
lambda. So I is these distances equal?
no.
No, but in part B, C, are they equal?
Yes.
Yes, and the another positive point is that this look a better diffraction path. So that's why part B is your answer. Okay.
Okay.
Now read M47.
The interference patterns from a diffraction grating and a double slit are compared. Using the diffraction grating, yellow light of the first order is seen at 30 degrees to the normal to the grating. The same light produces interference fringes on a screen of 1.0 meters from the double slit. The slit separation is 500 times greater than the line spacing of the grating. What is the fringe separation on the screen?
What is the frame separation on the screen? Okay. So what is been given the same light produces interference fringe on a screen. We have given distance, the slit separation is 5,000 times greater than the line spacing on grating. Okay. We need the fringe separation. So if we use the formula lambda equals to ax over d, we know that d lambda over x is equals to a. So the slit separation is equals to 5,000 time 500 times greater than line spacing. So slit separation is 500 times greater. So if I substitute it by d, which is n lambda equal to d sine theta. Okay, so it if we make subject e, it would be
D will be n lambda over sin theta.
yeah. So now tell me which set we will multiply by 500, d or a.
Mm.
The slit separation is 500 times greater than the line
So that
spacing.
the A will times by 500.
Yes. So it would multiply by 5. So it would be 500 into d into lambda over fringe separation equals to n lambda over sine theta. So we know that lambda would always lambda would be same because the it is the same light. The wavelength should be same. So we cancel it. Now what else we need? Yeah, now it is the question is pretty easy because we know that distance is 1 meter,
Like,
and so it would be 500 into 1 500 over x equals to n. What is n? What do you think n
the number
is?
the number of
Yes,
rating.
number of grating. So we know the first order, like the yellow light is in the first order, so n would also be 1 because they are saying the yellow light is of first order. So your n is
And
1 and sine 30. So now calculate x and tell me the answer.
okay, 250.
Sorry,
250
is a calculator in degree mode or radian mode?
degree.
Okay, so 250. What is sine 30?
Yeah. 1/2.
Try solving it by in radian mode first. But I think no, for certain degrees, no, it will still in degree. You don't have to do in radian because it is 30 degree, right? So you are saying that it's 250. So no, the answer is not matching. So let's see what a mistake we have done. So the formula for select separation we think is lambda equals to ax over t. We have to find x, so it would be d lambda over a equals to x. Okay. So for d we know it is 1. We don't know lambda. We don't know a equals to x. So instead of a, I would be saying that a is equals to 500 times of d. Yes or no? Instead of a, can I write 500 d?
Yeah.
Yeah. So it's equal to x now. Lambda equals to 500 into d. So for d we have formula n pi upon sine theta. So we know n is one order, so n would be 1. So it would be lambda over sine 30
30.
equals to x. So lambda is being cancelled. Now it would be x equals to 500 divided by sine 30 and 1 on it is your numerator, right?
Yes.
Now try solving it.
1 times 10^-3.
So 1 is C is our answer. Is it clear now?
Yes.
Okay, so we have made a error in the calculation. We should have done it by this way. We just have to substitute A by 500 D and then the whole working. Is it clear?
Okay.
So I'm sending you the link again. So join again before the time of the class is ending.